Morning class, this is gravitation part 6 and today we will learn effect on the gravitational acceleration g due to Earth's ellipsoidal surface. Now Earth is not a perfect sphere, actually it is quite elliptical in shape, and if we consider that the Earth consists of some elliptical disks like this two are polar region and this is the equatorial region. From here we can see that the width is maximum here in this equatorial region and the width in the polar region is minimum. So combining this all the disks we get this ellipsoidal surface of this Earth, and here we can see that if RE is the radius of this equatorial region and this RP is the polar radius, then from here and also from here we can say that RE is greater than RP. So from the universal law of gravitation we know that this acceleration is inversely proportional to r square. So g is proportional to 1 by r square. So if RE is greater than RP, then we may say that GE, that is the gravitational acceleration in the equatorial region, must be less than GP, that is the gravitational acceleration in the polar region. So GE must be less than GP, that is the gravitational acceleration in this region is less than the gravitational acceleration in this region. Now we will learn about gravitational field. Now what is this? Every particle in this universe attracts every other particle with a force called gravitational force. The space around the attracting particle in which the force can be experienced is called the gravitational field of that particle. Now if A is a particle and at a distance r from A there is another particle B, then due to the universal law of gravitation, as every particle in this universe attracts every other particle, so A will attract towards its center the particle B, and this particle B will also attract particle A towards its center, and around this particle A there is a space, and also around this particle B there is a space where if we keep any other particle, then that particle will experience an attracting force of this A or this B. Suppose this is the region of A, and if we put any object, suppose here, then this particle will experience an attracting force due to A, and if we put any object, this is the region of B, where if we put any other particle, then this will experience an attracting force towards the center of this B. So these regions where the attracting force of a particular object will be felt by any other particle, then that region will be called its gravitational field. So this is the gravitational field of A and this is the gravitational field of B. Now the intensity of gravitational field, what is that? The force experienced by a unit mass placed at a point in a gravitational field is called intensity of gravitational field at that point. That means that if A is an object and this is the A's gravitational field, then if we put any other object here of unit mass, suppose m, then the force experienced by this unit mass placed at the point P in this gravitational field of A is called the intensity of gravitational field at the point P. Now, suppose M is experiencing, this unit mass is experiencing the force F Newton, then the field strength, the gravitational field strength will be F by M, that is Newton by kg, and the dimension is L t to the power minus 2. Now, suppose an object of mass M is placed here, and at a distance r from this M another object of unit mass M is placed. So, the intensity, the field intensity, or first of all the force it will experience is G M M by r square. So, the field intensity will be F by M, that is equals to G M M by r square into this M. So, we will get the field intensity as G M by r square. What is the gravitational potential? This is the work done in bringing a unit mass from infinity to a point in the gravitational field is called gravitational potential. Suppose this is a gravitational field and we are bringing a unit mass at a certain point P in this gravitational field, then the work done in bringing this unit mass from infinity to the point P in this gravitational field will be called the gravitational potential at that point. Now, when we take a body away from a gravitational field, then the work is done against the gravitational attraction or the gravitational force, and when we bring a body from outside into a gravitational field, then work is done by the field, and here in this case the work done is positive and here in this case the work done is negative. So, the gravitational potential is negative. Now, suppose this is a gravitational field and we are bringing a body of mass M at the point P, then if the work done in bringing this mass M is W joule, then the gravitational potential at the point P should be V equals to W by M joule per kg, and this is, of course, as this is gravitational potential, this should be negative. The dimension is L square t to the power minus 2. Now, what is gravitational potential energy? The work obtained in bringing a body from infinity to a point in a gravitational field is called gravitational potential energy of the body at that point. So, if this is the gravitational field and we are bringing a body from infinity to a particular point P, then the work done or the work obtained in bringing that body from infinity to that point P is called the gravitational potential energy of the body at this particular point P. Suppose if we bring that body in this point P dash, then the gravitational potential energy of point P and of point P dash will differ. So, it particularly depends at which point we are bringing the body from the infinity, and at infinity this energy is 0, and as the work is obtained, so this energy, this gravitational potential energy is always negative. Now, suppose at a point P there is an object of mass m, and at infinity there is another object of mass small m, and we are bringing this object from infinity at a point P dash, and the distance between P and P dash is r. So the gravitational potential energy is U equals to infinity to r. This is the work done by the gravitational force on the particle as it moves from infinity to r. Now we know that work done equals to force into displacement. So we will get from here as this is the gravitational force and this is the displacement, and the displacement is from infinity to r. So this is F dot dr. Now we also know that this gravitational force is G into mm by r square. So we will replace this here. So we will get G mm by r square to dr. As this G mm part is constant here, so we will get after integration G mm by r from infinity to r, and this will give G mm by r. So this is the work done in bringing this object of mass m from infinity to the point r. That is, this is also the gravitational potential energy. So gravitational potential energy U equals to minus G mm by r.